discrete random variable is one which may take on only a countable number of distinct values. So, for example, the x values could be 0, 1, 2, 3, 4. When dealing with discrete random variables, there are three formulas that we need to know. And the first one is that the sum of the probabilities must always be 1, and that's true for any distribution. The second one is for allowing us to work out the mean, which we call the expectation of x, and that is the sum of the x values multiplied by their probabilities. And the third is for working out standard deviation. And standard deviation squared is the variance of x. And it is the sum of the x values squared multiplied by their probabilities, subtract the mean squared. And you'll sometimes see that written in formula books as the expectation of x squared. So that becomes an x squared p of x, minus the expectation of x, i.e. the mean, all squared. In this first example, we're given information about the expectation of x. And we're told that the expectation of x is 5/6. And we're going to use our formula. And that's the sum of the x values multiplied by their probabilities. So 5/6 has to equal 0 times 1/3, this x value multiplied by its probability, plus 1 times a, plus 2 times, and be careful here to use a set of brackets, 2/3 minus a. So 5/6 has to equal a plus 4/3 minus 2a. If I bring all the letters to the left-hand side, I'm going to get a equals 4/3 take away 5/6, which gives me that a is 9/18, which is 1/2. I redraw out the table and I replace a by 1/2, and that gives me that when x is 0, probability of getting a 0 is 1/3, probability of getting 1 is 1/2, and the probability of getting 2 is 1/6. I now need to work out the variance of x. There's a number of ways to set this out. I prefer to use the formula in this form: the expectation of x squared minus the expectation of x all squared. Expectation of x squared will be 0 squared times 1/3 plus 1 squared times 1/2 plus 2 squared times 1/6. So that gives me 0 plus 1/2 plus 4/6, which is 7/6. Then to work out the variance, I take my expectation of x squared and subtract my expectation of x, which was 5/6 all squared. So that's 7/6 minus 25/36. And that simplifies to give 17/36. Finally, in part C, I'm asked to work out the probability that the x value is less than or equal to 15. Well, all of these x values are less than or equal to 15, so the probability that it will be less than or equal to 15 is 1. In example 2, we're asked to find alpha, and this time I'm going to use the fact that the sum of all probabilities has to be 1. So 0.1 plus alpha plus 0.3 plus 0.2 plus 0.1 plus 0.1 has to be 1. So alpha plus 0.8 has to be 1. Alpha is 0.2. I'm then asked to work out the probability that x is greater than -1 and less than or equal to 2. Well, that's the probability that it could be 0, probability that it could be 1, and the probability that it could be 2. And from my table, that is 0.3 plus 0.2 plus 0.1, which is 0.6. I haven't included the probability of minus 1 because it's greater than, not equal to. Question 3, we're going to be using all of the formulas. So in part A, I'm asked to show that P plus Q is 0.55. So I'm going to use the fact that the sum of the probabilities is 1. So 0.3 plus P plus 0.1 plus Q plus 0.05 has to be 1. P plus Q plus 0.45 is 1. P plus Q is 0.55, as asked for in the question. A of x equals 2.75. So that has to be equal to the sum of the x values multiplied by their probabilities. So 1 times 0.3, 2 times p, 3 times 0.1, 4 times q, and 5 times 0.05, which gives us that 2.75 has to equal 0.85 plus 2p plus 4q. Subtracting that, 1.9 has to equal 2p plus 4q, and then dividing through by 2, 0.95 has to equal p plus 2q. That means I now have two equations and two unknowns. I have my p plus 2q equals 0.95, and I know that p plus q equals 0.55. So if I subtract those, p take away p is nothing, 2q take away q is q, and 0.95 take away 0.55 is 0.4. And if p plus q equals 0.55, then p must be 0.15. Now I have to work out the variance of x, and that will be the expectation of x squared minus the mean squared. So the expectation of x squared will be 1 squared times 0.3, 2 squared, so that's 4 times p, 3 squared, 9 times 0.1, 4 squared, 16 times q, and 5 squared times 0.05, which will be 1.25. Substituting the values for p and q, we get an expectation of x squared of 9.45. So the variance of x will be 9.45 minus 2.75 all squared, which is 1.887, to three significant figures 1.89. Final part of the question uses expectation of algebra, and if y equals ax plus or minus b, the expectation of y is a times the expectation of x plus or minus b. The variance of y will be a squared times the variance of x. So for this question, y is 4x plus 2. So the expectation of y will be 4 times 2.75 plus 2, which is 13. The variance of y will be 4 squared, so 16 times the 1.89, which is 30.2 to 3 SF.